Today, there will be a few things that I won't go over. One of those being basic tools, a mechanic's tool set, screwdrivers, basic everyday essentials that everyone should have on hand. Another thing that I won't be going over is proper lifting techniques of the heavy structural items. For more information on that, please consult your erection manual or the AISC handbook available online. When drilling your anchor bolt or drilling for base angle anchors, you'll want to use a rotary impact drill. These drills have different sized bits for each application. You want to make sure that the columns are plumb and square. A 6-foot or a 5-foot spirit level placed on the girts will tell you if they're in line. On larger buildings, I like to use a transit. This will allow you to verify the heights of each location throughout the building, one at a time, ensuring accuracy. If you find that a correction needs to be made, either the column needs to be tilted in or tilted out or one direction or the other, it's a good idea to have a standard crowbar on site. This will allow you to pry up one end of the column and slide a small shim underneath to ensure proper column alignment. On larger buildings, you'll probably need a piece of equipment to raise the beam so that you can shim underneath of it. When you're setting your anchor bolts, you'll want to use a 2-part epoxy. This product here is from Silka, available at the Home Depot or Lowe's. This is a great product for setting anchor bolts that are going to be used for non-load bearing columns or door jambs. In some applications, you can also use a wedge anchor. For your heavier bolts, if you are drilling and epoxying, it's a good idea to consult with a professional engineer or some known resource to ensure that you're using the correct product and drilling to the appropriate depth for your building. One thing that is absolutely critical on every job is the use of levels. I like to use these magnetic ones. That allows you to hold it up against a beam and gives you a free hand to work with. I use a 5-foot level and a couple of small spirit levels, or some people call them torpedo levels. You may find it handy, especially for the rake cuts, to use a reciprocating saw. This one here has a metal cutting blade on it, and it really makes quick work for cuts that don't have to be pretty because they'll be covered up by trim later. For installing jam trim, drip trim, your base trim, and for lapping trim, doing your corner boxes, you'll need to install pop rivets. The pop rivets are supplied by Great Western, and any 1/8 inch pop rivet gun will do the job. For larger jobs, you may consider upgrading to an electric or a pneumatic pop rivet gun. You'll also be attaching secondary framing. These are the light gauge members with the Great Western building. They're galvanized, they're the shiny metal ones, and I like to use a spud wrench. These members are pre-punched to align up with a hole in a clip that's been pre-welded to the column or the rafter. A spud wrench is great for this. They have a pointy end that allows you to slide the wrench through one hole and pull the steel in one direction or the other. You can then drop a bolt in the other hole and tighten it up. I really like these adjustable ones. These are useful all over the building, and you never know when you're going to be stuck up on a rafter and not have the exact wrench that you might need to pry a bolt loose or to tighten something up. While erecting your secondary, nothing is more aggravating than winding up on a rafter, trying to set bolts in place, and not having the hardware that you need. It's down in the lift, you're fishing for it in your pocket. If you have them, wear your tool bags. Sometimes anchor bolts aren't always perfectly set, and they'll be in on one side of the building, or there'll be a slight variation that may cause the need to make a small modification to some of the secondary members. Modifying secondary members is always preferable over to modifying the heavy structural members. When I say modifying, what I'm talking about is making a small hole, sometimes drilling in a complete new hole, or slotting a hole. I like to use just a standard battery-operated drill. I keep a couple of standard sizes on hand at all times, and that is a 9/16 drill bit. I keep a 1/4 inch drill bit, a few others, and I also like these nifty step bits. Step bits can be expensive, but if you have the resources or if the money's really not too much of a concern, these sure are a lot easier to use than a standard drill bit. There's a variety of hand tools that you'll find necessary. I've already gone over the spud wrench. I like the adjustable ones. These allow you to basically tighten or loosen any bolt that you may come across. I also like to have a variety of open-ended socket wrenches, and these ones here with the ratcheting in are especially nice. Of course, the good old-fashioned crescent wrench always comes in handy, and they're easy to stow in a back pocket or in your tool bags. As far as drill bits go, I like to have 9/16 readily available. I really like these step bits, even though they are expensive. I keep a 1/4 inch, I keep 3/16, and I keep 9/64. 9/64 are good for when you're doing pop rivets on your trim. Our pop rivets are supposed to be 1/8 of an inch, but I find that because of the paint, they're a little bit bigger than that, and using a 9/64 allows it to slide in a little bit easier. For 1/2 inch structural bolts or 1/2 inch A307s, the silver hardware that you use on your secondaries, I like to use an impact with one of these adapters for a 1/2 inch socket on a 3/4 size. That, with the 3/4 inch socket, will allow you to tighten up everything very fast. I've already gone over the impact, but I like to use, especially on a non-insulated building, an impact with a 5/16 chuck. The 5/16 chuck is usually magnetic and will hold the screw in place while you drill. Before you start placing sheets on your building, you're going to want to pre-drill them. Consult the erection manual and your erection drawings for how this is done or the proper method. You can pre-drill stacks of up to 10 panels at a single time. It's always a good idea to double check your measurement with what you have in the field. We like to use a 3/16 drill bit for lap screws, and we like to use a 1/8 or a 9/64 drill bit for the intermediate girts, and of course for the eave strut and the base angle. Same goes for your roof panels. If the building is insulated, oil canning can become a real problem. So you're going to want to make sure that you don't accidentally over torque or over tighten the wall screws. Basically, the insulation will compress and it'll leave a dimple on the panel. This isn't as big of a problem in a non-insulated building or a building like this where the insulation is installed after construction or after the installation of the wall panels. If your building's insulated, it may be a good idea to pick up a tech gun or a tech screw gun. This has a clutch mechanism which allows you to set the force so that you don't accidentally over tighten or under tighten your screws. When it comes time to cut your sheets, either at the rake, at the peak of the roof, or around door openings, the most useful tool, and something that I consider absolutely necessary, is the angle grinder with a cutoff disc. I prefer to use this tool only for cross cuts on the panel. For longer rip cuts, and a mainstay for any professional erector, is the electric shear. This is something that not everybody's going to have, but it sure does come in handy. For tight panel trimming and for your trim work in general, you'll want to have red and green handled shears, left cut and right cut, and a larger set of shears that'll make long, smooth cuts. If you have it available, the electric shear also comes in very handy for trim work.